All right. Yes. Welcome, viewers. Yes. Thank you so much for your support. You guys are my motivation, and I cannot thank you enough. Thank you so much, guys. Please, if you are not subscribed to my channel, kindly subscribe. Help me share also. Please help me share and also comment. Yes. Thank you so much. So in this video, I'm going to be taking you on Alkylhalides. From the name Alkylhalide, as you can see on the platform, you will see it that the title was Alkylhalide. And with the inscription I gave on the board, I have alkane minus hydrogen equals to alkyl. That's the first thing you have to put in your head. That when you remove a single hydrogen from an alkane, a precursorial alkane, you are going to get the corresponding alkyl, which entails that when you subtract one hydrogen from ethane, you are going to get ethyl. So it means if this is ethane and you subtracted one hydrogen from ethane, you are definitely going to get ethyl. And if this is methane and you subtract one hydrogen from methane, you are going to get methyl. So it means that alkane are saturated while alkyl group are unsaturated. For any chemical compound to involve in a reaction, they have to be unsaturated. So an alkane cannot mingle with another element to perform any reaction. So to make this alkane radical, that means to be able to have at least one free side to bond, we need to subtract one hydrogen. It is when we subtract one hydrogen, the halides will now come in replacement of this hydrogen to give us alkylides. So what am I trying to insinuate? It means, let's say for instance, you have methane. Methane cannot react with any of the halides. Halides are halogen, as you can see, fluorine, bromine, chlorine, and iodine. So this halide cannot come in into this methane because it is saturated. At this edge, it is very, very saturated. Why? Because carbon like to bond four bond as a measure of the fact that carbon is in group 4. So all carbon should have 4. So once they get their 4 bond, they are satisfied. So that satisfaction is what we denoted or depicted as saturation. So for this methane to become unsaturated so that it can be used in reaction with the halides, we have to turn it to what we call alkyl group. So as it stands, this molecular formula is for alkane, a methane. So for us to make a methane unsaturated, I am to subtract one hydrogen. So when you do that, you are going to get methyl. So a methyl is a radical because the carbon want to bond 4 bond, but at this instance, it's only having 3 bond. So it is possible for us to input any of these halide because halide also are in group 7, and all elements in group 7 we know that they have 3 lone pairs and 1 bond electron. Fluorine, for instance, since they are in group 7, 1, 2, 3, 4, 5, 6, and 7. So whenever you see a pair of electrons are at the configuration of an atom, it is called lone pairs. So this is the only available single electron. It's only single people that search for partners. So it's only this single electron that can be used in bonding. So we call this bond electron. Why we call these pairs? We call this one bond electron, while the pairs are regarded to as lone pair. So the bond electrons are single electrons, while the remaining one, the pairs one, are called lone pairs. So this 1, 2, 3, you can call them lone pairs. So as a result of that, lone pairs of electrons are not used in bonding. They are not readily used in bonding. So the only available electron in group 7 element is 1. That means fluorine, bromine, chlorine, and iodine. I only use fluorine as a representative example. What I said about fluorine goes for all. That means fluorine only have 1 bond electron. So that means the same function that this hydrogen that we subtracted from methane is doing, the halogen can also do. So whatsoever hydrogen can do, halogen can also do because they both bond 1 electron each. So by the time you subtract the one hydrogen from methane, it becomes a radical which is now free to react. So when you now pick any of the halide, another name to call halide is halogen. So let's say for instance I want to use chlorine here. The chlorine will also be a radical. By the time they come together, two radicals. Radicals is an any element that have at least that is deficient in an electron. So by the time they come together, both of them are deficient. By the time they come together, they're going to give you methyl chloride. So the methyl is the alkyl, while the chloride is the halide. So alkylhalides can be defined as a derivative of alkanes in which the hydrogen atom is substituted by one or more halogen. The more hydrogen you substituted, the more halogen becomes in. That means the more hydrogen that you displaced from the chain, the more the halogen.